Support for today's Heat Treat Radio episode is provided by Heat Treat Today's 40 Under 40 Class of 2023. Learn more about the award at www.heattreattoday.com/40under40 promo. And welcome to Heat Treat Radio, a podcast from Heat Treat Today. Whether you're listening to us or tuning in via video on heattreattoday.com/radio, we're glad to have you. Today's episode illuminates how Gary Sharp, founder and CEO of Advanced Heat Treat Corp, began the company. Gary will also highlight the technical capabilities of ion nitriding, including the common applications, real benefits, and limitations of this process. Let's tune in with Heat Treat Radio host and Heat Treat Today publisher, Doug Glenn, now.
Gary, first off, welcome to Heat Treat Radio. Really glad to have you here.
Thank you.
We're going to do a little bit of talk.
Folks.
What's that?
I say enjoyed meeting you folks.
Yeah, it was very nice meeting you too. So we're going to do a little bit of talk today about something that's near and dear to your heart. And I know it's interesting to a lot of our readers and listeners, those manufacturers who have their own in-house heat treat and also some commercial heat treaters as well. We're going to be talking about nitriding, specifically ion nitriding. So Gary's got a long history there, right? I mean, you've been involved with this for quite a while. So we're going to talk about that and some of the technical aspects of ion nitriding. So let's get started with this, Gary, if you don't mind. Before we hit the record button, we were talking about the history, and I'm kind of interested to hear a little bit about the history of the corporation and you as well. So if you don't mind, tell us a little bit about yourself and the company.
Well, I started with John Deere in the chemistry department. I have a degree in science chemistry. And then I went into various other areas, production support and different management positions before I end up ultimately leaving to start Advanced Heat Treat. And the way I became oriented and introduced to ion nitriding was a company who we had done work with wanted to sell John Deere, some new technology. And so they came in for some meetings, and we had, several meetings with top management, but that was right at the 79, 80 was one of the first real downturns in the ag market.
Yeah.
So Deere wasn't really interested in taking on a new technology at that time. And ultimately, while I was still interested, I talked to various management people. Ultimately, I got permission to invest and investigate on my own the ion nitriding process, because that
even while you were still at Deere.
While I'm still Deere, I had to do it on my own, and so
on your own.
Yeah.
Gotcha.
So, all my vacations, my holidays and things were spent doing market surveys, talking to various potential users and so forth in the marketplace to see if it seemed to have a fit, because obviously when an equipment supplier comes in, everything is nice and rosy. And
yeah. And it works for everything. Yeah.
That's not always the case, of course. So,
right.
But like I say, after discussion with the management, they gave us permission to continue our investigation. And so we, from like 79 to 81, we did a lot of research. I took vacations and went and did market surveys with different potential customers and so forth, and found out that it still seemed to have a lot of the glitz and the shine that the company that came in to talk to us proposed that it did. So we went ahead and after a period of time and evaluation, put together an investor base, put together and building equipment was purchased and so forth. And then we began to do ion nitriding. We started with a lab unit, a 25 kW lab unit, and a 160 kW unit that we would transfer from development into production size lots.
Yeah. A quick question about that, because you say we, so this was not Deere though. These were the people outside of Deere, yourself and some others.
Yeah, it was myself and several others at the time.
Very interesting.
Like some things happen and partnerships aren't always the easiest. And
Yeah,
so
yeah.
that
Right,
ultimately dissolved, and it was
right.
pretty much me and my wife and
Yeah,
our employee base. So
yeah.
in any
No, I
case,
hear you. I hear you.
yeah,
Yeah.
that was the start anyway. And the trouble is, early on, the small lab unit worked fine, and we could do our development, but it didn't transfer over to the larger production unit. We kept having power supply issues, and this went on for months and months and months. And ultimately, I had to get legal involved. And that churned around for over a year probably. Here we're trying to have a startup business, and at the same time we're fighting with everything else. The building came together good, the lab we put in worked good, but we just had issues, and we weren't aware of it, and we weren't aware of how many pieces of equipment had been sold in the marketplace by this company, and until we got into legal, and then we started having more serious discussions. But ultimately, they replaced the power supplies with a new source, and consequently solved the arc suppression problems and some of the things that were taking place. Because basically, what would happen, we get into the range of an unstable arc discharge, and instead of heat treating, we were melting the parts.
Yeah.
And unfortunately, we couldn't keep many customers doing that. So
No.
case, that got resolved. We got additional equipment in the settlement and so forth, and then we took off.
Yeah.
And
Now that was, when did you actually start the company then? I mean, when did the lab and the production?
81, 82 timeframe, yeah.
Gotcha.
And we had, from the market surveys, we knew there was considerable interest, and obviously went back to some of those folks and started doing some development work with them, particularly on applications where ion nitriding was a significant advantage over some other treatments. Because where I was, the plant I was at in Iowa, they were doing gas nitriding on cylinder liners. But again, like you say, with the market going south for a while, they weren't interested in any new technologies. And so just continued to do the gas nitriding.
Right. All right. So you ran through a little bit of legal issues, got that. When would you say, Gary, was the first time that you really felt like, okay, we're up and running, we got the, pedal to the metal, so to speak?
I think last week, maybe.
Yeah.
No,
I hear you.
It took a while, but in our investigation and so forth, and we found out that they'd sold quite a few pieces of equipment, and they'd all been mothballed and put on the shelf. And in a way, it was a bad deal, but it was good for us because we had the solutions to fix them. So I went around and purchased equipment 10 cents on the dollar and bought additional capacity. And we'd get up around 70-80% of capacity on one vessel, and I'd go buy another and get it set up and established in our plant. So it worked out quite well for us, being dumb and stupid, I guess, at the same time.
Well, you did the proverbial made lemonade out of lemons, right? I mean,
something like that.
Yeah, that's great. That's very, very good.
Kind of evolved over time. I mean, we've got 50 plus units now, ion nitriding as well as gas nitriding and so forth. But the nitriding field has been our baby for many, many years. And we've done a lot of development with other suppliers and so forth to make sure that the applications that they have got the right process. Gotcha.
Very interesting. Yeah, appreciate you sharing that. So let's talk a little bit about nitriding, generally speaking. Then I want to hone down in a little bit more into ion nitriding, because we're going to assume that people that listen to this don't necessarily know the difference. And I think that's probably a safe assumption. Most of the world doesn't know the difference between ion nitriding and any other type. But let's just and we don't need to spend a lot of time on this, but just on a high level, Gary, if you don't mind, just tell our listeners, what is nitriding? What is that? What are we doing, and why do we do it?
Nitriding is a case hardening process, and it is used on a variety of components to improve wear, abrasion resistance, fatigue strength, and so forth. And it's generally a lower temperature process and say carburizing or anything like that. So you don't have the resultant distortion, pulse machining requirements and things like that you do with some of the existing treatments that were out there. And like you mentioned, there's ion nitriding, there's gas nitriding, there's salt bath nitriding. All three do similar things. They just have different requirements, obviously, for the material, the chemistry that it's involved with each of those materials. But you can nitride most anything, at least putting a compound zone or an outer layer on that's very abrasion resistant. Where the process gets developed is when you have alloy, chrome, moly, vanadium, aluminum. These are nitride formers, which combined with the nitrogen at and below the surface to give you a diffusion zone that has longevity and a very high hardness and so forth.
Right. So in the simplest terms, nitriding, right? I always try to explain to people that don't know it, because you've talked about case hardening and diffusion zones and things of that sort, which is probably Greek to people, but to some people. But in one sense, what we're doing is hardening the surface of a metal by infusing nitrogen. Basically, I mean, that's about the simplest way we can say it. So that's what it is. And it's done in a variety of different ways. And that's what I wanted to ask you a question about this. It can be done, you mentioned already, gas nitriding, you mentioned salt bath nitriding. And then, of course, we have ion nitriding. So, and we'll talk a little bit more about, obviously, we're going to talk most of it today about what ion nitriding is, but let's talk about if the total universe of nitriding is 100%, what percent of that do you think is gas nitriding, salt nitriding, and ion nitriding? Best guess.
I've heard different numbers. Ion nitriding has grown significantly over the years. Up until that point, it was probably gas nitriding and salt bath nitriding were probably 70%, 80%, I would guess.
That's right. Yeah. And I just wanted to give people a perspective, because this is, I mean, ion nitriding has been around a long time. It's still a relatively small portion, but it's got some very unique benefits and that we want to talk about. And it's not necessarily for everybody, but it's a great process. But I want to give people just a sense of the total market. So gas nitriding is probably the 800-pound gorilla in the room, right? Salt bath nitriding is done a decent amount. We've actually talked with a company recently who does that. We've had them on Heat Treat Radio. They do that. And ion nitriding is one very important one it's kind of neat, actually. I've actually seen some ion nitriders in action. So
it's quite visual, the purple glow and so forth. That's why I got purple tie on.
I was going to say, wonder why you have the purple tie on there. Wonder why www.ahtcorp.com on your, it's purple. That's obvious. We will include some images to show people if they haven't seen it. So, okay. So let's talk a little bit about, we won't go into the details of any of the gas nitriding or the salt nitriding. Obviously, that can be a topic for another day. But let's talk a little bit about how is it that ion nitriding ultimately gets the nitrogen into the surface of the metal. How does that happen? How does that differ from, if you will, gas and or salt?
Well, it's a diffusion process, and when you create the plasma, if you look at a piece of equipment, the hearth plate is a cathode in a DC circuit. The vessel wall is the anode, and your gas is your carrier. And so through the transfer of energy, you bombard the part with ions and neutral atoms. They transfer their kinetic energy, and that's what actually heats up the parts. In the early years, that was the only way you could heat the parts. And later, more developed equipment, now you have auxiliary heating in the walls as well, which adds some advantage, but it also adds a little more complexity in terms of keeping and maintaining a current density on the part adequate to diffuse into the metal itself. And so sometimes you put it in a vessel and you turn on the power supply and all the energy is coming from somewhere else, and you don't actually diffuse or harden the part itself. So it's been solved obviously over the years, but that's something that on the surface was often overlooked.
So, right. So is it safe to say then, and as far as getting the nitrogen into the part, that in a sense you're making a positive and a negative charged item, and the
ions bombard the surface.
Right. So the ions bombard it because they're attracted by magnetically, if you will, and then
they transfer the kinetic energy, and that's what heat the workpiece up in the early equipment. Like I said, in later equipment, they had auxiliary heating as well in the chambers, but.
So, right. Okay, good. So what are some of the more common applications? I know you started out there with John Deere, obviously, right? They were interested. Is it mostly agriculture or is it other stuff now?
No, by no means, because when I was still at Deere and left Deere, we made sure we didn't have conflict of interest. So I didn't even solicit any Deere parts at the time.
Okay.
And that went on for quite a few years. And, since we've done parts for them and so forth. But anything that has high wear and abrasion, one of the advantages that we haven't talked about is the ability to selectively harden and the ease of masking. And I say ease of masking means that instead of using copper paints or stop-off materials, you can just interrupt the plasma from touching that surface. So if you have some threads, you just put a nut on there, it blocks the plasma from touching the threads and they won't get hard.
So it's actual physical block.
Physical block, yeah. And you have maybe a 8 to 10 thousandths, 8 to 15 thousandths gap, and you still don't diffuse beyond the masking itself. Mm-hmm. So there's a lot of ways of masking parts with ion nitriding, either mechanically, and those are generally done on customers' parts that are repeating. So you don't have to paint them every time they come in, let the copper paint dry and all that type of stuff. We just would use mechanical masking and just use them over and over, and they basically last forever.
Right. Yeah. I've heard one of the other real advantages of ion nitriding is blind holes and areas like that where gas flow wouldn't necessarily get, and salt might have a little bit of difficulty getting.
Mm-hmm. It is an advantage. There is an L over D ratio we have to be aware of, because as you conform that plasma to go down in the hole, if it intersects itself with the other side, it's called halocathoding, and that is extremely hot and can melt the parts. And that's what happened early on with, before we got some of the equipment issues resolved, is that we would get in that unstable arc discharge range and we'd basically melt the workpiece. And the customers weren't too happy with that. So
no, it's a bad day when you open the furnace to a pool of metal. That's not a good day. Yeah.
When we return, we'll wrap up the conversation on advantages of ion nitriding and talk about some of the real-world applications and limits of this technology. A quick word from our sponsor. Heat Treat Today's annual 40 Under 40 award goes to young folks in North America's heat treat industry who are giving their time, talent, and education to make the industry a better place. Who are these rising young leaders? Likely your own clients and colleagues. A nomination takes just 7 minutes, so go to heattreattoday.com/40 under 40 promo now. Winners receive year-long recognition on www.heattreattoday.com and are featured in the September Trade Show magazine. We need your help to locate the hidden heat treaters who discreetly work away from the public eye, especially those who are operating an in-house heat treat operations. Who do you think is a rising young leader in the North American heat treat industry? Type heattreattoday.com/40 under 40 promo to nominate or learn more today. Once more, that's heattreattoday.com/40 under 40 promo. Now, back to the episode.
So we've got certain benefits there. Basically, any industry you're saying can do it if there's anywhere where there's high resistance. So automotive parts, yes.
Automotive, aerospace. We have parts. We did the submarine gear for the Seawolf submarine, 35,000 pounds, 160-inch diameter. And now and that ran probably 400 plus hours, not because it was big, but because they had an extremely deep case requirement. So the diffusion took longer, particularly at the lower temperatures that you run versus other kinds of treatments.
Right. And you mentioned this earlier. Oh, go ahead.
Go
Sorry.
ahead.
I was just going to say, you mentioned it earlier, but I wanted to mention it again here. One of the advantages of nitriding, generally speaking, ion nitriding as well, is that you're typically below the temperature where you got to start worrying about distortion, right? I mean,
Yeah.
you're typically you're there, so you're not going to have to do that post hardening, any type of grinding or straightening or things of that sort, generally speaking.
Yeah, that's one of the big advantages for sure. We found that a lot of customers, and that's one of the reasons they transitioned out of one process into ours, was because we eliminated some subsequent operations, which they typically had to have, which reduced their cost, even though it wasn't a direct cost in nitriding. It definitely affected that.
Yeah. Very good. So I'm sure with most every technology, there are common either perceptions or misperceptions about problems with that technology. Can you address what do the common man out there, the common guy who's going to be involved with trying nitriding, ion nitriding, what might they hear would be some of the problems with ion nitriding, and can you address them, whether they're legit or not?
Well, loading a chamber and the part spacing you need to, depending on what level of vacuum you're going to run at, it'll determine how wide the plasma is. Well, that in turn affects then how close you can put parts together or close to each other, so that you still get treatment on both products or both pieces, if you will.
Right.
And it does allow you to do mix loads of different types of things, depending on, again, the level of vacuum and how wide the plasma that you're conducting, if you will, surrounds that part.
Right. So that is a concern.
Yeah. And that's why, we review all those, and generally we'll even run some test samples for the customer, let them compare our metallurgy with theirs and so forth. And before they commit even further production loads. But we've run parts. We had a steering torsion bar. We probably ran 10,000 pieces in a load.
Yeah.
And we masked the bottom portion of that because it got cross drilled in the assembly. And of course, they didn't want to have to drill through a hardened piece of material.
Yeah.
So
right.
Consequently, it worked out really good for us. And we did that for 15 years, probably 20 years.
Right. How about, I have heard that when you're ion nitriding, part cleanliness is a critical part. Can you address that?
Yes, of course, we clean everything before it goes in the chamber. Typically, it has been either with an alkaline wash or vapor degrease to get rid of any contaminants off the surface. The early part of the cycle, when you turn the DC power supply on, you begin to sputter. So any oxides and things like that are on the surface get sputtered away before you actually ramp up and start the diffusion phase of the cycle. So cleaning is important. If you have plating, that often blocks out. If you have dirty parts, that will prevent nitriding, or even worst case, it'll sputter off and onto other parts, and then you contaminate those as well. So cleaning is an important part of the equation.
Right. That's good. Any other common misperceptions about ion nitriding that you'd want to address? If not, that's okay.
I don't know anymore. Back then there was, when we first started, and that's how we learned some of the things that we did, of course. But the spacing is important. The gaps are important so that you don't have a cathode. And then, like you touched on a little bit ago, the cleanliness. I mean, if it's really dirty and contaminated, you're going to have a void in that area, and Nitride. So
Yeah, get a soft spot, so to speak,
Right.
because of, it could just be, I've heard it could be something just as simple as oil from the skin, from your
Mhm.
person's, the skin,
fingerprint or anything like that. Yes.
touching the parts and stuff like that. So, okay. Yeah, but cleanliness is typically not an issue. I mean, you guys know how to clean, any parts shape, so I'm sure it's not an overcomable issue, obviously. So,
Well, it's getting more difficult right now with them wanting to restrict the use of vapor degreasing and things like that as well.
yeah.
We have to
Yeah.
come up with other cleaning methods that are suitable and
Yeah.
still meet the end product requirements.
Yeah. I'm not going to go there.
I'm sorry.
You and I probably would agree on this. I know we've not talked about this in the past, but I think the way some of the things they're restricting right now is kind of, it's a little interesting, but I'm not going to go there. So don't get me started, Gary. Okay. All right. Well, that sounds good. So we covered a bit of we covered the benefits pretty much of anything else as far as benefits, though. Let me just throw that out to you. Anything as far as benefits go?
I mean, obviously wear and abrasion are big ones, and then treating them at a low enough temperature that you don't have distortion, you don't have to set up and post heat treat machine. Those are all, key benefits from the process itself.
Right.
But it's repeatable. Over and over, we do thousands and thousands of parts and loads at our different locations and so forth. And it's been quite successful for us.
Let me ask you this question, Gary, and then we'll wrap up here in just a minute. But let me ask you this question. Can you put that ion nitriding in perspective, or nitriding generally in perspective, with things like ferritic nitrocarburizing, maybe just carbonitriding, whatever? Where does it fall on the scale? What are the differences between those processes?
Well, the ion nitriding is most effective when you have chrome, moly, vanadium, aluminum, those types of elements in your product.
Okay.
And of course, with carburizing, that's not a requirement. Carbonitriding typically isn't a requirement. And both of those processes are done at considerably higher temperatures, which then gets you back into the question about, is the part going to distort? Do we have to post-heat machine and things like that? So that is a big difference. Gotcha.
Okay. All right. That's super. And before I got one last question for you about people who are potentially could use your services, but I want to dive a little bit deeper into your company now. Before we wrap up, you've got 3 locations now, correct?
We have 4.
4 locations. All right. Where are they?
3 of them do ion nitriding and the nitriding process. Here in Waterloo, we have the corporate headquarters, which we have the largest ion nitrider. As a matter of fact, we're installing one right now that'll do parts upwards of about 30 feet.
Wow.
And
okay.
So it's big chambers. But in any case,
you got Waterloo, Iowa.
Waterloo, and we have the 2 facilities here. That's where we started.
Gotcha.
It was risky enough leaving John Deere without going somewhere else. Then we added Michigan, and Dr. Rolinski was our key go-to guy up in Michigan.
Ed Rolinski,
he lived with me for a year and a half.
Did he really? That's pretty cool.
We were building the facility in Michigan, so he could go back to it.
Okay, great.
And then we started a plant in Coleman, Alabama.
Gotcha.
So we kind of get the central Midwest pretty well covered with all types of applications. We're starting to add some other types of treatments, the black oxide treatment and some of those at the locations as well, to kind of subsidize the ion nitriding, if you will.
That's the Ultra Ox?
Ultra Ox, yes. Yep.
Okay, gotcha. Yeah, very good. All right, well, let me wrap up with this question then. So let's say there is a company out there, a manufacturer, who currently is doing some sort of a case hardening process. And they're thinking, wonder if I should look into nitriding / ion nitriding. What would be your guidance for them? What questions should they be asking themselves?
Just send them to us. Save the headache.
Spoken like a true businessman, Gary. I appreciate that.
All kidding aside, no. They kind of have to go through some of the same steps we did early on, go through the testing, make sure the parts, the treatment, whatever they select is repeatable, and it fits their end use. And I mean, it's rather expensive equipment. Some of these are in excess of $600,000-$700,000 a piece, depending on the sizes, even get more expensive than that. So,
well, you're talking about them buying
a piece of equipment.
Well, I'm even talking about what should they be thinking about if they even decide I'll outsource it, like to your company, because I know it should be clear that your company doesn't make the equipment, correct? You're basically
we make some of our equipment now.
You do, okay?
Yeah, we do. We have in the past, particularly when there's things that weren't available.
Right, but you're not necessarily in the business of selling ion nitriding equipment. You make your own.
No.
Okay.
Sure,
All right.
yes.
So back to the question. If a company's out there and they're thinking, wonder if I should ion nitride, not necessarily meaning buying a piece of equipment, do it in house, but what are the questions they should be asking? For example, I'm thinking to myself, I've got X part. Is this part? Is it possible that I could ion nitride it? What about that part of me?
You'd start first with the material chemistry.
Yeah.
And see what materials they're using. And obviously it has to fit the requirements of the end application as well. That's probably the biggest thing. And then if it's got alloy in it, then you figure out your case steps and your diffusion requirements and so forth. And then they'd probably do some development testing on parts and see how it worked in their application and go from there.
Gotcha. Okay. All right. Yeah. And it's probably best just to ask an expert, like you said. I mean, your first answer was probably actually a pretty good one. Just send them to us. That actually makes some sense. At least call, right? I mean, at least call and check it out. So maybe one last question. Is there any part, or maybe there's more than one? I'm sure the answer is probably there's more than one. That if you have this part, you shouldn't even consider ion nitriding. It's not going to work. Threw you a curve on that one.
I'm thinking the biggest concern you have on assuming the material's compatible with the nitriding reaction, then I would take things with blind holes or holes that they want hardened, but we can't conform the plasma tight enough to get down in those holes to where you'd have hollow cathode, and then you could have a melting issue or damage issue to the parts. That would be probably the biggest thing. And parts that have to be nitrided all over. Oftentimes in those cases, you would nitride for half a cycle and then flip them, because where it's sitting is actually getting masked. Where it's sitting on the hearth plate or on your fixture plate or something like that. So those are the kinds of applications that you have to give more thought to.
Okay. Great. All right. Very good. Well, it's a great start. It's good introduction to ion nitriding. I appreciate your time, Gary, and we'll make sure we put up your information on the screen so people can get a hold of if they want to, which I recommend. Just from my perspective is, you guys have been around a long time, basically as long as I've been in the industry, and your reputation it's a good reputation. You got a good reputation for doing great work there. So I hope people will get in touch with you.
And we try to take care of them, and we stand behind our work and do what people expect you to do.
Yeah, exactly. You do the right thing, which is important. All right, Gary. Thanks very much.
Well, thanks for your time. You take care.
All righty.
We hope you enjoyed listening to today's episode with Gary Sharp. Give Heat Treat Radio a 5-star review or like on Spotify, Apple Podcasts, SoundCloud, iHeartRadio, Podbean, or the website www.heattreattoday.com/radio. If you'd like to get in contact with Gary or learn more about Advanced Heat Treat Corp, head over to www.ahtcorp.com or call 319-232-5221. You can also reach out to me and I can put you in touch. My email is bethany@heattreattoday.com. We love hearing what topics would best help you better run in-house heat treat operations. If you have an idea or a technical topic that you want to hear discussed on Heat Treat Radio, let me know. Also, if you'd like to sponsor a future episode, let me know at bethany@heattreattoday.com. Heat Treat Radio would like to thank Heat Treat Today's 40 Under 40 class of 2023 for sponsoring this episode. Nominations officially open on May 22nd, 2023 for this year's class. Learn more or nominate at www.heattreattoday.com/40under40 promo. This and every other episode of Heat Treat Radio is the sole property of Heat Treat Today and may not be reproduced in part or in whole without advance written permission from Heat Treat Today. And I'm Bethany Leone. Thank you for listening.